Now we want to solve this differential equation, which is given over here. Let's first convert it into the notation form in the operator d. So what do I mean by this? I can write this also as d3y minus 6d square y plus 11 dy, okay, minus 6y is equal to 0. Therefore, if you just take y common or factor out y, this will become d cube minus 6d square plus 11d minus 6 and times y is equal to 0. On the right hand side, since it is 0, we know that particular integral is going to be 0, and the solution of this differential equation is just going to be y is equal to CF, which is complementary function. Now let us see how do we find complementary function. In order to find complementary function, as we discussed, we need to solve auxiliary equation. Okay, auxiliary equation is nothing but FD is equal to 0. That's the auxiliary equation. Okay, remember this is auxiliary equation. Okay, we need to solve this equation in order to find the complementary function. Okay, so now FD, which is function of D, is right here. So we substitute that. So we have D cube minus 6D square plus 11d minus 6 is equal to 0. Now we need to solve this equation and find the value of d from here. Now since this is cubic equation, we'll have to do something called as synthetic division in order to find the values of d from here. Okay, so in order to do synthetic division, we need to find at least one value of d. If you try value of, let's say, d is equal to 1, let's see if d is equal to 1 satisfies this equation. If you put 1 here, so 1 minus 6 minus 5 plus 11. So minus 5 plus 11 is plus 6, and then plus 6 minus 6 is 0. So that means we know one root is for sure d is equal to 1. Okay, so we know d is equal to 1 is one root. And if we want to find another root, we do synthetic division by just something like this. So we just draw a horizontal line, a vertical line. We know that d is equal to 1, we found is one root. So we just write 1 here and just write the coefficients here. So 1, minus 6, 11, and minus 6. Okay, and then take this 1 below. Okay, multiply this over here. So 1 times 1 is 1. Add these results. You get minus 5. Again multiply. 1 times minus 5 is minus 5. Okay, then 11 minus 5 is again 6. And again multiply this. 6 times 1, you get 6. And 6 minus 6, here you get 0. So one root is d is equal to 1. And the other root, so if one root is d is equal to 1, we can say that d minus 1 is equal to 0 is one factor of this equation, of this cubic equation. And other factor will be from here. Okay, it will be d square. So 1d square minus 5d plus 6 is equal to 0. So this is another factor. Okay, so you are basically splitting that cubic equation into two factors. D minus 1 is equal to 0 and d square minus 5d plus 6 is equal to 0. So therefore, so you can write this cubic equation as d minus 1 times d square minus 5d plus 6 is equal to 0. Okay, I hope that synthetic division makes sense. You would have done that in somewhere in your class 10th or class 11th. But if you have any questions, feel free to post it in the comments on synthetic division. So here you can just write this equation. You factor out 6, so you get 3 and 2. So you just can write d square minus 3d minus 2d plus 6. So you can just write that minus 5d as minus 3d minus 2d is equal to 0. I hope you know how to solve quadratic. So therefore, you have d minus 1 times, if you factor out d from here, so you have d minus 3 minus 2 factor out from here common. So you have d minus 3 again is equal to 0. So therefore, you have d minus 1. I hope you can see that one factor is d minus 3 from here and other factor is d minus 2 from here is equal to 0. So basically, I can say that therefore, either d minus 1 is 0, or if product of three numbers is 0, either the first number is 0 or the second number is 0 or the third number is 0. Okay, or I should say d minus 2 is 0. Therefore, I get either d is equal to 1, or I get d is equal to 3, or I get d is equal to 2. So basically 1, 2, and 3 are the roots of that cubic equation. So we get the values of d. Since these are, now let's get back to our case. So if we get the values, unique rational values, so since these 1, 2, 3 are unique and they are rational values, the complementary function is just given by c1 e to the power ax, c2 e to the power bx, and c3 e to the power cx. So I can just write it like my complementary function is given by c1 e to the power 1x plus c2 e to the power 3x plus c3 e to the power 2x. The sequence doesn't matter here, okay? You can either write 1, 2, 3, 1, 3, 2, and so on, but this is your complementary function. Therefore, your solution in this case is nothing but just a complementary function, okay? If you remember from the top, we just have y is equal to cf, okay? Because our particular integral is 0, because our right hand side is 0, the solution of this differential equation is just y is equal to CF. So therefore we have y is equal to CF is our solution. Therefore y is equal to C1 e raised to x plus C2 e raised to 3x plus C3 e raised to 2x. This is the solution of the differential equation that we want to solve. I hope that makes sense. Let's